All right, today we're going to talk about medians and altitudes of triangles. Now, if you notice, medians is underlined because really we're going to focus on medians today. Tomorrow we'll talk about altitudes. As I said, we're splitting this up over 2 days. So today we're going to talk about medians of triangles, section 5.3. Now, when you think of medians, or you hear the word medians, what do you think of? Middle. Okay, so medians are talking about middle. So what we're talking about is kind of like the middle of the triangle. All right. So here's the vocab. Again, we're going to focus on the first two today. We're focusing on these top two today.
Oh, that's it?
The median of a triangle is a segment whose endpoint are a vertex of the triangle and the midpoint of the opposite side. So if you look at it here, let's say I draw a right triangle. And there's my midpoint. The median goes from the vertex to the opposite side's midpoint.
Oh, yeah.
It is the median. Okay. Now, if I were to draw a triangle with all three medians, the point of concurrency of the three medians is what's called the centroid. Now, it's called the centroid, and it's also known as the center of gravity. That is unique because what happens here is, let's say you make a triangular figure, okay, and you were to find the center of gravity, or that centroid. That's basically like the balance point for that triangle. So you can hold that triangle up like with your finger, and that'd be the center of gravity, the balance point there. Okay. Centroids are used a lot of times just with balance points. Have you ever heard of center of gravity, balance points before, right?
Yeah.
Sure, in science and different things. Yeah, that's used in a lot of different aspects of science and math. So it's the centroid, it's the center of gravity. And that's found by using the medians. All right. So here's what this looks like. Okay. The medians of a triangle. They're conjoined using the vertex and the midpoint. So notice here, the median goes from the vertex to the opposite midpoint. In a median, does it have to be a right angle there?
No.
No. Okay, so recognize perpendicular bisectors, they go to the midpoint at right angles. Medians do not. So recognize the difference there. Okay. Does everybody see how it cuts the segment in half over here?
Where?
Like it goes to the midpoint,
yes,
so it cuts it in half?
Yeah.
Great. Now we're going to talk today about the centroid theorem. Now the centroid of a triangle is located, what they say is 2/3 of the distance from each vertex to the midpoint of the opposite side. I am instead going to talk to you about the 1/3 rule. Okay, because it's kind of easier. Now what this says is, let's say I take the segment here, AH. So if you look at AH here, right? What this says is if AH is 3, then NH is 1 and AN is 10. There's 2. Okay, so it's saying that this is located 2/3 of the way from the endpoint. Okay, so the centroid is located 2/3 from the endpoint. What I'm going to tell you today, it's actually easier to start from the midpoint. Okay, so instead of thinking of it as 2/3, let's think of it as 1/3 from the midpoint. Because it's a lot easier to divide by 3. You guys ever know how to find 1/3? Just divide by 3, right? So for instance, let's say I switch this up. Let's say this whole distance is now 6. Well, what's NH going to be here? I divide that by 3 and I get 2, which means AN is now 4. Okay. Now, what's the relationship between the short side, the red line there, and I'll make this the purple line. What's the relationship between the red line and the purple line? There's one's 2 and one's 4.
Yeah.
If you ever think about that mathematically, what's the relationship between them? It's half the other one. The short one is half of the longer one. Okay, yeah. And we're going to use those properties to help us today. So let's say, for instance, let's say this whole thing is 30. Well, what's my small segment here going to be? 10. Because it's 1/3 the whole segment. And then if I double that, I get the other segment, which is now 20. Now, Caden, let's use that same philosophy here. It's all right. Caden, what if I said AN here is 10? If I said AN is 10, now what's NH?
5. 5.
Oh.
5. Now I cut it in half. Does that make sense? Now that makes my whole thing 15. So again, what we're going to talk about today, it's always easier to actually find the shorter segment first. Now, on some of your assignments, they might ask you for the longer segment. That's fine. Find the short segments first and then go from there. It makes it a lot easier to work with. So let's look at number 1. In triangle QRS, RX is 48. So I'm given RX here is 48. Does everybody see RX? 48. And it says QW is 30. Okay. So RX is 48, QW is 30. Now again, the first one says once we find RW. Before I even work some problems out, let's just find the missing parts. Can I find WX here?
Yeah, no.
Yes.
Yes.
Remember, my whole segment's 48.
48 divided by 3.
So if I take 48 divided by 3, what's our WX have to be?
I don't know.
That has to be 16.
And wouldn't it be, since those are, what is it called when it goes in the middle and 3 goes in the middle?
And what?
Wouldn't those lines be the same? Each line would be
No. That's the centroid, bud. Okay. So this is 16. What's RW going to be now? I double that and I get 32. Now, does that make sense? Does 32 plus 16 equal 48? Yes, that'd work. Now let's do the other one here. If QW is 30, what's WZ going to be here? 15.
How do you get that?
Because it's half of that.
That's the only way out.
That'd be half. So let's look at number 1 here. Now it says once we find RW. Well, we already found it. What's RW? 32.
X.
Number 2 says WX. Hey, we already found that. What's WX? 16. 3, QZ. Well, QZ is the whole segment here. What's the whole segment going to be, Reed?
5.
How'd you find that, Reed?
I don't know, I just added 15.
30 and 15. You get 45. And the last one, number 4, WZ. What's WZ? 15. We found that already as well. So again, it helps to find the smallest segment first. Because then you're just dividing, and then you're just multiply from there. Let's try a second set here. Okay. In triangle HJK, it says HD is 21. So HD here is 21. Then it says BK is 18. So BK is 18. I want to find some segments lengths. So let's start here. Let's find CB. Does everybody agree you can find CB right away? What's that going to be? 9. Right? Because I take 18 divided by 2. CB has to be 9. Does everybody agree with that?
Yeah.
Okay. Let's find BD next. Now, does everybody agree? HD is 21, right?
It'd be 7.
So I take HD of 21, divide that by 3, and I get 7. BD has to be 7.
14.
And then HB is going to be what, Reed?
14.
How'd you find that?
I don't know. Added 7. Or 21 divided. 21 minus 7.
21 minus 7. You take the whole segment minus a part segment, you get the other part, right?
Yeah.
Could I also take 7 times 2?
Because
Wouldn't 7 times 2 be 14 as well? Great. So now let's fill in the missing parts here. Number 5 says find HB. Well, what's HB? We found it already. It is 14. 6 says find BD. What's BD?
7.
Found that one already too. 7, CK. What's CK? 27. How'd you find that, Ty?
You add CB and
Yep.
BK together.
CB and BK. That gives me the whole segment. 9 plus 18 is 27. Nice job. And last one, CB. Well, we already found it. What's that?
9.
There it is. Again, always start off with finding that shorter segment. It will make everything else a lot easier.
Is that all we're doing?
Take a couple seconds, try these 4 on your own. All right. So it tells me RS is 21. It tells me VT is 5. Okay. So let's work it out. Number 9, I want to find RV. Well, what's RV going to be, Caden?
RV?
Yeah.
RV would be 14.
RV is 14. Nice job. How'd you find that, Caden?
Because half of 28.
What? 14 is not half of 21.
You know what? I think you should take that home.
Anderson.
Reed, how'd you find that?
RV,
Yeah.
because RS would be 21.
So VS
And then you
is.
divide by by 3 and it'd be 7. So the other one had, you have to double 7, so it'd be.
That's how you explain it. Nice job, Reed.
Yeah.
Number 10, TP.
Why would you divide that by 3?
Because you have to find the shorter segment. The short one is always 1/3 of the whole segment. Okay, so TP. I want to find TP. What's that, Brock?
15.
How'd you find that?
I saw that was 5,
Yep.
and then it looked double on the other side.
So this is 10.
10.
So the whole thing is going to be.
15.
Good job.
This is
Number 11,
when you
SV.
Highlight and write.
Tyler, what's SV?
7.
Yep, already found that. 12, VP. Spencer, what's VP? Already found that too. Nice job. That's 10.
This is like one of the few John.
Try these 4 as well. Take a couple seconds. Same idea. Try these 4. All right, here we go. Let's try this here. Use the figures for exercise 13 and 16. GB is 20. So GB here is 20. And I know that CD is 15. Okay. So when I work that out, let's talk it through here. What's FG going to be? Beast, what's FG going to be? 10. How'd you figure that out?
It's the smaller side.
So it's just half of 20, right? Great. What's GD going to be? Trent Bannister, what's GD?
GD,
Yeah.
that would be 5.
How'd you figure that out?
Well, since CD is 15.
Yep.
So
15 divided by?
15 divided by 3 would be 5. And
Great. Yep. So what's BF going to be then, Anderson? What's BF?
25. 30. What?
30.
Reed, you led me wrong.
It's 30 because 20 plus 10 is 30. I want the whole segment here. 20 plus 10 is 30. And then last but not least, I need CG. Blake, what's CG going to be? 10. Because you just do 15 minus 5, right? And you get 10.
You're kidding me.
There you go.
Reed.
Here's your assignment.